again, and this is my presentation for IMAPS and DNS. And this is again for System Security 2 at Kennesaw State University. So IMAPS, which stands for Internet Message Access Protocol, secure. It's the secure encrypted version of IMAP that uses SSL or TLS to protect data as it travels between an email client and a mail server. With IMAPS, emails stay stored on the server instead of being downloaded and removed like with POP3. This means that you can access and manage your emails from multiple devices, and all changes like reading, deleting, or organizing messages stay synchronized. Some features with IMAPS: it also lets users manage messages directly on the server. You can sort emails into folders, flag important ones, save drafts, and even use RAID receipts. Essentially, it acts as the middleman between your email client and the mail server. Some ports and advantages is IMAPS communicates over port 993 by default, while IMAP uses port 143. Because of its server-based storage encryption, IMAPS is especially useful for people who need secure access to their mail while traveling or switching between devices. IMAPS with Dovecot on Linux. Dovecot is a popular open source mail server for Linux that works alongside IMAPS to securely receive and manage emails. Step 1 is to install Dovecot. This setup begins by installing the necessary Dovecot components by using apt. The Dovecot core package provides the main service, while the IMAP and POP3 daemons handle incoming mail connections. Step 2 is create a user and mail directory. So next we would create a local user account that will own the mailbox. Using user add and the pass wd, we set up credentials. Then we create a mail directory, or mail dir, one word, which is where Dovecot will store incoming messages for that user. And then step 3 is allow IMAPS traffic. So we also need to make sure that the firewall allows IMAPS traffic on port 993, and that is done with the UFW allow, in quotes, Dovecot secure IMAP command. And then step 4, test the server. Finally, we test the configuration by logging in and using the mail command to verify that messages can be retrieved and stored correctly. IMAPS with Dovecot hardening recommendations. First, we want to restrict access. One of the most effective ways is to harden your IMAPS and Dovecot setup, and we do that by restricting who can connect to it. Using the system firewall, we can limit access to specific IP ranges or trusted networks. This reduces exposure to brute force attempts or unauthorized users. With strong authentication being next, it's important to enforce strong authentication. Every user with mail access should have a complex password policy, and ideally, multi-factor authentication should be used. This will add an extra layer of protection even if credentials are compromised. And lastly, regular updates and patches. Finally, routine software updates are key. Vulnerabilities in mail services are constantly discovered and patched. So staying current is critical, and by running sudo apt update and sudo apt upgrade regularly, you make sure your mail server meets the latest security standards. Just remember, you'll need administrator privileges to do this. Now DNS, which stands for Domain Name System, is a system that translates human readable domain names like www.example.com into machine readable IP addresses such as 192.168.11, and this is necessary because while humans prefer to use readable domain names, computers and networking equipment use IP addresses to identify and communicate with each other over the internet. Now, without DNS, users would need to memorize long numerical IP addresses to access websites or services, and DNS acts like the phone book for the internet, making it easier to navigate for us. Different types of DNS servers are DNS resolver, recursive DNS server. This server is the first point of contact in the DNS query process. When you type a domain name in your browser, the DNS resolver takes the query and looks for the IP address. If it doesn't have the answer cached, it passes the query through the other DNS servers to resolve it. Example, the DNS resolver that your ISP provides, or public resolvers like Google's, is 8888. Another is root name server. This is the first step in translating human readable domain names into IP addresses. And when a DNS resolver cannot find the answer locally, it queries a root name server. These servers are located worldwide and manage the top level domains, TLDs, like .com, .org, and country codes like .uk or .us. Now, top level domain, TLD, name servers is after contacting the root name server, the query is passed to the TLD name server, which is responsible for storing information about domains that end in specific TLDs, example .com, .net, .org, and it directs the DNS query to the authoritative name server for the domain. And authoritative DNS servers. This server provides the final answer to the DNS query, and it holds actual DNS records for the domain, such as the IP address, or mail server information. It directly responds to the DNS resolver with necessary IP address or resource, completing the DNS lookup process. DNS with IIS on Windows. To start off, on Windows systems, Internet Information Services, or IIS, can also be configured to act as a DNS server. Before setting it up, you'll need to make sure your server meets basic requirements like having administrative access and a static IP address. The first step is to install the DNS role. The first step is to install the DNS server role, and this can be easily done using PowerShell with the command install-windows feature-name DNS. Running this enables the DNS server on your Windows server. And step 2 is configure IPs and interfaces. After installation, we configure which interfaces or IP addresses the DNS server will listen to, and this is done in administrative tools under DNS properties, where you can input the allowed IPs, and configuring this correctly ensures only authorized traffic reaches your DNS server. To wrap up, with IIS configured this way, the server can handle DNS queries internally or externally, depending on your network setup. DNS with IIS Windows hardening recommendations. Using DNSSEC. DNSSEC is an added layer of security when making DNS queries by authenticating DNS responses. This prevents malicious attacks that can be levied using domain name systems such as DDoS attacks. Locked DNS cache. Caching is to speed up DNS queries by reusing information, and this information can be compromised by hackers to reroute the cached DNS request to a malicious website or file. And configure access control lists, or ACL. Limiting who has access to the DNS server prevents users from either querying for malicious websites or updating DNS records. Implementing ACLs will make it so only people with proper authorization can update and query the DNS server. DNS with bind on Linux. One of the most, enable DNSSEC. One of the most effective ways to secure DNS on on Linux is by enabling. I'm sorry, wrong slide. I'm just going to read from the slide. Bind, which stands for Berkeley Internet Name Domain, is a Linux-based tool for setting up DNS servers to resolve domain names into IP addresses. Install bind using the command apt install bind9 utils bind9-doc -y. Modify the config under this directory, etc. bind named.conf.options to set parameters like allow query for IP access control. Validate with named-checkconf. And configure forward and reverse zones in this directory, etc. bind named.conf.local by copying and editing the db.local file to your IP, and then restart the server and test with ns lookup space bind server. DNS with bind hardening recommendations. In bind recursive, to disable recursive queries, in bind recursive queries can be useful for resolving external domains, but they also open the door to amplification attacks. Disabling recursion by adding recursion no to the configuration file ensures that your server only answers queries for domains it is authoritative for. Next, limit query rates. Another important defense is rate limiting, and by setting the responses per second parameter, you can allow how many DNS responses the server handles at a time, and this prevents flooding and helps mitigate denial of service attacks that overwhelm DNS service. Denial of service being DDoS or DOS. Enable query logging would be next, and so finally, enabling DNS query logging is an essential monitoring tool. It helps administrators detect suspicious requests, identify traffic anomalies, and take action before a threat may escalate. Logs provide valuable insights into ongoing attacks or misconfigurations too. And to wrap up, together these three steps, disabling recursion, limiting queries, and logging activity, this will significantly strengthen a Linux-based bind DNS server against common exploitation tactics. These are my references, and I hope you guys enjoyed my presentation. Thank you guys for joining.